What's going on, Algebra 2 students? Let's get this party started. Let me just kind of move things around a little bit so that we can see things a little bit better. Can I read that? Maybe do one of these. Pull this over just a little bit. Pull this open. And up. And pull this wider. There we go. Alright. Can you see my face? Half of my face, at least. Yes, can you hear my voice? Talk to me, folks. You guys got it? Yes, hello? Alright, awesome. Let's get started on this thing, and I think that so far for your homework, what I have set up for it is I have you guys turning in this thing today, and I realized that I don't know if I lectured on it just yet, which is kind of a punk move of me. So I need to start getting crack-lacking on doing some lecturing. What I need to do is I need to get up in front of the things. So I'm actually debating. I got a question for you guys, and I want you to kind of answer me honestly. Do you guys feel like we're going too fast? Do you feel like you guys have enough time to, like, after you get the lecture, you guys see it and hear it and all of that kind of stuff? Or do you feel like I'm just being a punk and like assigning you stuff before I even have a chance to talk to you about it? Let me know your thoughts. And I need you to all chime in because there's a possibility here that I might be pushing your homework back. Unless, of course, you chime in. Alright? Perhaps a little bit. I'm not going to be angry. I'm not taking down names. I'm not going to say, well, this person thinks I'm mean. No, relax. We're talking here. We're having a conversation. Do you guys feel like... Because I'll tell you one thing. I feel... Yes, some of the work isn't what you go over. Okay. All right, I'll tell you what. Why don't I do this? Why don't I push my assignments back? And it's going to take a little bit of time because I got to go and individually do this. But why don't I push my assignments back 3 days? All right? That will give me some time to lecture on these things before you have to turn it in. Because it's not fair. You're absolutely right. It's not fair of me to make you turn in stuff that I haven't lectured on. Does that sound fair to you? Now, if it doesn't sound fair to you, don't say anything. And if it does sound fair to you, say something. Hello? Please, anyone say something. There we go. Sounds good. It could be 2. What do you mean 2? You mean 2 days? You want 2 days instead of 3? Oh, I'll tell you what, Joy. Why don't I just be a nice guy and give you the 3rd day? I'm going to push all of my assignments back 3 days. I think I have a few final exams. I can't move those, obviously. Those have to be where they're at. But I'm going to push everything back 3 days and give us some time to have some breathing room here. Because, you know, I feel a little bit pressured, too, to get through all this stuff. So I want to make sure that you guys are able to. I'm doing my class a little bit differently because my glass isn't working. It's because my camera's not working on my computer. It's not working correctly, at least. Anyway, why don't we get started on this thing? Tommy the turtle. All right, ready? Tommy the turtle stands on the edge of a cliff and tosses a pebble into the ocean. Why does it have to be a turtle? I don't understand, because turtles don't inherently toss rocks. They don't have opposable thumbs. You can ask the biology teacher that and talk to him about that. But anyway, whatever. I wouldn't want you... Oh, Joy, I'll tell you what. I am willing, and I've had you before in my class, and I hope that you feel this way, but I, as your teacher, am willing to put in that extra work to move all of your stuff back, and, you know, move all of the assignments, if it means that you guys will be more successful in your studies. So if you guys are willing to put in the work, then I'm willing to put in the work as well. Okay? I'm not going to hold you to the system that I originally said just because it's convenient for me. What I want to know is what is best for you. Yes, obviously I want something that's convenient for me. What is best for you? Okay, and Erica, I will make sure to read, or I will make sure to respond to your question as soon as possible as well. But for now, why don't we start off with this week's material? And I know that you just came in. I think that what I'm going to do is talk to the counselor and see exactly when you came in and say that, you know, I'll take a look into that situation. All right, anyway, Tommy the Turtle, the non-opposable thumbs, apparently is able to throw a pebble, which is pretty impressive, probably with his mouth, into the ocean, and the graph of the height versus the time is given below. So it looks like this. And you've seen this arc in the past. Okay? This arc, actually, you know what? It didn't start at the ground. It actually started at 100. You've seen this arc in the past, and the way where you've seen it is, I mean, you've seen it when you throw things. This is called a parabola. This is a function, all right? And that's where we came up with this parabola thing that we're talking about. It originated, you know, like I always ask you to ask me, why should I care? And you should care about this because what we're doing here is we're mapping out motion. We're mapping out what we see in the real world. And apparently it has this funky looking shape. And that funky looking shape actually is not funky looking at all because we're very used to it. It has this very familiar shape to us. And it's familiar to us because it maps out things that are being thrown. Anyway, let's see, what do they say? The types of questions we are going to answer regarding Tommy's pebble include: how high is the cliff? How did the pebble travel before it began to fall back down? When did it reach its highest point? When did it hit the ground? We will return to solving these questions in the future handouts as we build enough skills and familiarity with quadratic functions. Now, this is an Algebra 2 course, so you should know quadratic functions in Algebra 1. That should be something you guys are pretty familiar with. But like I said, we're still in review mode, so we're going to be kind of going over this kind of stuff. All right. In a previous lesson, we reminded you that linear functions is a function that can be symbolically represented by fx equals mx plus b. I probably wrote it down as y equals mx plus b. It's the same thing. We replaced fx with y. It's just the fx is a little bit more detailed. It means a function as it depends on x. Now, with quadratics, what we're going to have is anytime you have a square term on that x, you're dealing now with a quadratic function. So your equation, your graph, isn't going to be a straight line anymore. It's going to be a curvy looking thing like this. So the general function that we give to it, you know how, like I told you, if you change for the y equals mx plus b, all right? There's these two variables here. These two numbers here tell you characteristics about how that line works. If you change the b, that will tell you where that line intersects with the y-axis, right? You guys agree with me? Okay, and if you change the m, that will tell you how slopey the line is. If it's a big M, it's very slopey. If it's a small m, it's a little slopey. Now, there's a general equation for quadratics, and that looks like this. Y equals ax squared plus bx plus c. Now, I'll give you a hint. This is called standard form, and I think it's the most useless form of the forms of the quadratic. It's not very useful at all. I mean, it is useful, and it's useful when we start hitting this thing called the quadratic formula, but it's the most useless of them all. But this A, this B, and this C, will change the characteristics of how this graph looks. I'll give you a few hints. See this A here? This A is, did my camera just freeze? Hold on. Alright, the camera just froze. But does the video still, or does the audio still work? Oh no. Okay. You know what, you guys? I'm going to have to my camera just stopped working, didn't it? Manning, as kind of an emergency fix, can I borrow that until 9:40? 20 minutes? Yeah. You guys, while the video is not working, let me get something up and running so I can start writing to you guys. But for now, why don't we do this? All right? I'm going to start teaching you from this thing right here. Okay, let's close this program. All right, here's my question. Does the camera's not working, so I'm not able to show you my screen and whatnot. But I'll give you a hint. What I'm looking at here is this. Can you guys see the little red mark cursor moving along? Actually, Manning, I don't need it. I'm just going to teach it straight from here. Can you see this little red cursor moving along? I'm going to teach you with my mouse. I'll do my best. And it might look like I'm writing with my left toe. But, alright, so see the A over there? That will tell you a characteristic about that parabola. About that shape that we saw earlier. That shape that we saw earlier is this parabola-looking thing. I'll give you a hint. That A right there, if it's a positive number, the parabola opens upwards, which is actually opposite of how this thing works. It will actually kind of look something like that. If the A is negative, then it will look more like tossing something. I say that it opens downwards, its mouth is downwards. The A also tells you the shape of the parabola, whether it's fat or skinny. I'll explain that to you more later. But for now, let's go through this. How can we tell if these things are quadratic? Let's take a look at these. We have, you know what? Since we're running out of time because we've had so many technical issues, I'm just going to have to tell you right now. And actually, exactly, Erica. You look at this, and if the x is squared, then it's quadratic. Now, the second one, is that quadratic? You have an x squared in there, but is it a quadratic equation? Yes, the x is squared, but I want to know, is it a quadratic equation? Hello? Is anyone still there? If you don't know, say IDK. At least I know you're still paying attention. Okay? Not sure? Alright, I appreciate your honesty, and that's exactly what I want you guys to be able to do. That way, at least I know that you guys can hear me, and my audio didn't stop working. Alright. The question that I feel like you guys are having is that 0 on the x squared term. Now, if there's a 0 out in front of it, then what is 0 times x squared? It's still 0, right? So essentially, you can just kind of get rid of that part right there. So even though you see an x squared term, it doesn't actually have an x squared term because there's a 0 in front of it. So essentially, this function right here is not a quadratic equation. It's actually a linear function because the x only has it only has a x to the first power. Does that make sense to you? Yes? No? IDK? Awesome. All right. Now for I think what you need to turn in for homework, we need to start getting jamming on that. Let's go for it. The easiest functions to understand are and manipulate are linear functions. The next easiest function in terms of increased difficulty is quadratic equation, which a function that can be written in the standard form. Now, I'll be honest with you, like I've said before, this standard form is not very helpful all the time. It's kind of it's kind of like the worst way to write your function if you want to manipulate it. I'll show you different ways to write the function, but for now we are introducing to you just the standard form. So there's an A, there's a B, and there's a C. And the quadratic ends with a if you look at the last half, the bx plus c, that's kind of like the mx plus b. It's a linear function, but when we slap on the quadratic part, ax squared, then all of a sudden it becomes this very different looking function. Now the simplest quadratic equation to plot is pretty straightforward. If you want to plot something like this, x or f of x equals x squared, this is the standard quadratic equation. And you know what, for plotting, I'm going to use this. In fact, I'll tell you what, I'm going to teach you guys how to cheat. Give me a second, let me just start sharing my, darn it, I can't share my computer screen because Java doesn't work on this thing. Have you guys seen a quadratic equation? Let's see, can I do an HTML kind of deal? Here, let's see. No, let's see. I'll tell you what, here, try this. Go into the address bar, type in Desmos.com. I think it's just Desmos, D-E-S-M-O-S. You guys got it? I'll type it too. It's a graphing calculator. Alright? Now, what I want you to type in is just y equals x caret 2. Y equals x squared. This, my friends, is the most standard parabola. I'll draw it very, very poorly right here. Kind of looks something like this. Although it should be a lot more, prettier. And if we wanted to plot points, which is probably the most standard way of graphing, it's the most time-consuming way of graphing something, but it's also one of the safest ways to graph something. You would plot points here, and you would just say, all right, y equals x, or like if I have x squared, I'm just going to plug in 0 for the x. So what is 0 squared? That's 0. What is this number over here? That's 1 squared, which is 1. What is this number here? That's 2 squared, which is 4. What is this number here? That's 3 squared, which is 9. And this number is 16. The reverse goes over here. And then over here, you would put in what is 1/2 squared? Well, then that's 1/2 times 1/2, which is 1/4. This is 1/9, this is 1/16. And if you were to plot those points, it would give you this U-shaped formula, which we call a parabola. All right, I'm on page 4 now. So, we talked about the domain and the range. And remember how I talked to you guys about what a function is? A function has both an input and an output. Agreed? Go back to the computer screen, let me know. It has an input and an output. Now, the restrictions that we put on the input, that is our domain. The range is the restrictions on what comes out. So, for our function, what we've been putting in is the x values. Those are the inputs, right? Those are called the independent variable. The thing that comes out is this thing on the left side, which is the k of x or g of x or h of x. That's your out. And that's called your dependent variable, and it makes total sense because what comes out totally depends on what went in the first place. So what the range is associated with is the things that come out of the function, so it's the k of x part. Does that make sense? And I'll be honest with you, given the technical difficulties I'm having today, I almost feel like it would be appropriate of me to not just push your assignments back 3 days, but maybe even a week. I'm going to debate that question and see what is the most fair thing, because I don't even think that I'll get ahead enough to lecture on this and give you time to do it. That might push our schedule back a little bit, but I'm fine with adjusting that if it's going to mean you guys learn better. All right. So what this part of the lesson is telling you, and I really wish my webcam would work, but it's apparently not working. My webcam doesn't work. My audio at least is good. And at least you guys can see the computer screen. But what this is going to do is this lesson right here kind of tells you what to do with the coefficient a. It's the number in front of the x squared term. So that a, what that does is it changes the shape of the graph. Now you can plot points, and you can plot points, and you can draw those points on this graph and graph it. All right. Now when you do your homework, I want to see you do that. I want to see you plot points and draw on that graph. But for now, let's see. For now, what I would like for you to do is, what I'm going to do is go to Desmos. And the sad thing is I can't show you what I'm doing on the computer screen, so I'm going to give you the instructions. Go back to the desmos.com, desmos.com, and put in y equals x squared. Press enter. You should get a parabola. All right? Now type in y equals 1/2. Press the right arrow and put x squared. And tell me, what is the different graph that you get? Tell me what the similarities and the differences are of those graphs. Can you see? What's the difference between y equals x squared and y equals 1/2 x squared? Let me know if you guys know what I'm talking about. If not, I need you guys to at least say something, because I want to make sure that the audio didn't cut out or something like that. You guys tend to be awfully quiet. Let me know what's going on. And you know, I'm going to send out an email and say, what's the deal with, alright, I'll tell you what, Erica. I'm going to log in from a different computer, and I am going to change the presenter mode. I'm going to keep my audio going, and we'll see what I can do. Maybe I can make this better. Alright. I switched that. I'm going to share my computer screen. Can you guys still hear me? Yes, yes, you can hear me? All right. Let's look at if I can do something different. All right, let's see. Run this application. Oh, my Java is not updated. It almost feels like today's class is everything that can go wrong has gone wrong.
Yeah.
I apologize. I truly do. Let me update my Java. Okay. Thank you, Erica. I'm sorry, I'm looking at the wrong computer screen, and it took me about 3 minutes to respond to your question. But you're absolutely right. The parabola became wider. While I'm trying to get my other computer screen to work, so I'm working on that so that I can share my desktop with you and show you what I'm talking about. But you're absolutely right. When I tack on a 1/2 in front of the parabola, it gets wider. When I tack on a 2 in front of the parabola, what does that do? It makes it skinnier. Absolutely. Absolutely. Very good. When I tack on a -2 in front of it, do you know what that does to the parabola?
Have been kicked from this conference.
Turns it upside down. Very good. Can you guys still hear my voice? I'm trying to get some tech stuff worked out here. Awesome. Okay. So that is absolutely right. So what it does is it makes it skinnier. It makes it. If I have a 2 in front of there, it makes it skinnier. If I have a 1/2 in front of there, it makes the parabola fatter. And if I have a -2, it turns it upside down. Now what we're going to examine is we know what the A does. Okay, what we've been examining is what does that A in front of the x squared do? Okay? And if it's, and I would write these rules down, or at least, think about these rules. If A is a positive number, and if it's a number that's bigger than the number 1, it makes that graph skinnier. If A is a fraction, but it's still positive, it makes that graph fatter. I call it the gain weight plan, the cheeseburger plan. So the number 2 is kind of like your slim fast pan, and this one's the cheeseburger plan. This one makes it skinnier. This one kind of makes it a little bit horizontally stretched. Actually, I kind of better think of it as vertically compressed. And then this number right here makes the parabola turn upside down. Does that make sense? So the smaller the absolute value, the wider the parabola. Yes, absolutely. The closer the number is to 0, the wider the parabola is. Does that make sense? All right. Man, now the other computer's freaking out. I'm having a good technology day today. I'm so sorry, you guys. I feel like this. I try my best to present to you guys the best class possible. And yet, what happened? My camera doesn't work. I can't show you my computer screen. I can't upload my other computer because the Java's not updated. So I can't get that thing to work. Today is a talking kind of day. All right. Now look at this. Let's look at this. Okay, wait. And my boss wants to see me in 5 minutes, so I got to go talk to them. Okay. All right. Let's try this now. Can you guys see my computer screen now? Wait. It's still going to load up. And while it's loading up, this might be the last thing I get to do. I promise I'll have all of these bugs fixed to the best of my ability by Wednesday, the next time we meet. Okay? Yeah, this whole thing's probably not going to let me do anything. All right, I'll tell you what I'm going to do. Because I had all the technical issues that I have had, I wasn't even able to teach you what I wanted to sufficiently teach you today, in today's lesson. So what I'm going to do is I'm going to push everything back by a week. That means all of your due dates are going to be moved back. That gives you some time to work on this stuff, and it gives me some time to start lecturing it on Wednesday. I'm going to have to end class now, and I apologize. I truly do. I did my best, but I feel like it didn't really work out today. It didn't all come together. So for now, why don't we end class, and I'll see you guys on Wednesday. All right. Now, I'm going to stop the archive, and then Kaylin, I have a few minutes